Hi everybody, welcome to this series on formal fallacies. My name is Matt and I will be your instructor here for this series. I'm a friend of Dave's and Dave was nice enough to invite me here to speak a little bit about logic and to teach a little bit about logic as well. In this introduction video, I'd like to accomplish two things. First, I'd like to go over the structure of the series, just describe how each video will be presented, and then I'd like to offer some prerequisite information that you should be familiar with prior to jumping into the series. And I'd like to just preface that by saying that this introduction is going to be rather informal. It's not meant to be all-inclusive. It's just meant to offer enough information so that you'll be comfortable with jumping into the series as we move along with these formal fallacies. So let's get right into it. First, we should ask ourselves, what is a formal fallacy? And as you can see here, it says that a formal fallacy is an error in reasoning deriving from the logical form of an argument. And what this means is that when we're looking at formal fallacies and when we're looking at formal logic in general, we're not really concerning ourselves with the content of the argument. That is, we're not concerning ourselves with the lexical semantics of the argument. Rather, we're concerning ourselves with what we refer to as the form of the argument. That is, we concern ourselves with the logical structure and the logical sequence of the argument. And why avoid formal fallacies? Well, simply put, formal fallacies render arguments invalid. And what this means is that if we argue and we have a formal fallacy within our arguments, then the truth of our conclusion is not guaranteed by the truth of the premises that precede it. Each video will answer two main questions. The first one is, how is this formal fallacy employed through natural language? And I'll run through a few examples of how you may encounter the formal fallacy as a means of argumentation by means of natural language. The second question is, what is the form of this argument? That is, what is the propositional form of the argument? If we take the argument and we strip it of its lexical semantics, what exactly are we left with? And we'll go over the propositional form of the argument. And each video will end with a proof of the argument's invalidity by means of a truth table. That is, we'll end each video with a proof of the invalidity of the logical form of the argument. Next, let's jump into a brief overview of the grammar and syntax of propositional logic, as well as a little bit of predicate logic. However, for the intent and purpose of this series, you really just need to concentrate on propositional logic. To begin, propositional logic utilizes what we call propositional variables. So these are usually capital letters that are stand-in variables for propositions within natural language. So essentially, we're reducing a proposition to just a variable. So let's say we have the proposition, it is raining. What we can do in propositional logic is just present this with the letter R. If we want to say it is not raining, all we have to do is incorporate our logical operator for negation, this one here, and have R right next to it. And we have, it is not raining. Let's say we want to have a little bit more of a complex proposition. We can say something like, it is raining and it is not sunny, right? So we have our propositional variable for it is raining. We have our propositional variable for it is sunny. We negated that proposition, so it turns into it is not sunny. And then here we have our conjunction operator, which works like an and operator. So we have the expression here, it is raining and it is not sunny. The logical operators, we'll get into the meaning of them shortly. And as you can see here, the propositional variables of propositional logic can be presented in a number of ways. We can present them using subscripts, so we can have something like p sub 1, p sub 2, p sub 3, all the way out to p sub n, and this ensures that we will never run out of propositional variables. The most common way I think that you'll see them, especially here in this series, will be using capital letters from the English alphabet. The most popular of which are P, Q, R, and S, but you'll also see and run into propositional variables like A, B, C, D, E, F, G, etc. And some writers prefer to use lowercase letters rather than uppercase. Next, let's talk a little bit about the logical operators. The logical operators of propositional logic are what allow us to take what we call atomic propositions and turn them into compound propositions. So we go from a simple proposition to something a little bit more complex. And in propositional logic, we have 5 main operators. We have our negation operator, we have our conjunction operator, we have our disjunction operator, we have our material implication operator, and we have our biconditional operator. Predicate logic also uses these 5, but they add a couple more. For one, we have the universal quantifier, and we have a second one here called the existential quantifier. And keep in mind that the logical operators that you see here, languages are not limited to just these that you see here. We can also have logical operators like this vertical line. Let me draw that a little straighter. This vertical line, which is referred to as a Sheffer stroke. We can have something like this guy here. We can have something like this one here. These are all valid logical operators. However, for the intent and purpose of this series, all you have to concentrate on are these 5 here. And it's worth mentioning that we can actually get away with only using negation and conjunction within propositional logic. That is, the rest of these are technically superfluous. However, they do make things a lot easier in the sense that they allow for a pragmatic approach. So let's jump into the meaning of these logical operators. Let's see how they work. Let's see what they mean. The first one here, we have our negation operator, and that's represented by this little sideways L that you see here. And you can think of this as the not operator. So let's say again we have our proposition R for it is raining. And if we want to negate it, instead of using a separate propositional variable, all we have to do is stick our negation operator out in front of it, and we go from it is raining to it is not raining. And it's important to keep in mind that the negation operator is what logicians refer to as a unary logical operator. And this is because it only accepts one parameter. So we can't have something like not PR. This would not be what we call a well-formed formula within the language of propositional logic. Also, we can't have something like not QS. Even if we have the 2 propositional variables within parentheses, it's still not a well-formed formula. Our next operator here, we have our conjunction operator, and that's represented by the ascending wedge here. And you can think of this as the AND operator. So we can have something like R for it is not, R for it is raining, and it is not sunny. And the conjunction operator is what logicians refer to as a binary operator. And that is because, as you can see here, it accepts 2 parameters. Each parameter, the one on the left and the one on the right, these are each called conjuncts. Next, we have our disjunction operator, and that's represented using this descending wedge here. And you can think of this as the OR operator. So we can have something like it is raining or it is sunny. And again, this one is also a binary logical operator. We have 2 parameters here, and each parameter of a disjunction is referred to as a disjunct. Next, we have our material implication operator, and that's represented by this arrow pointing to the right. And you can think of this as the if-then operator. So we can have something like, if it is sunny, then I am happy. And this is also another binary logical operator. It accepts 2 parameters. And each parameter has a special name. The left parameter is called the antecedent, and the right parameter is called the consequent. The antecedent is the condition that is to be met, and the consequent is the result of that met condition. Next, we have our biconditional operator, and that's represented by this double arrow here. And you can think of this as the if and only if operator, or the IFF operator. And this one works like this. We can have something like it is raining if and only if rain is falling. So this allows us to go both ways, right? So we can say if it is raining, then rain is falling, and if rain is falling, then it is raining. And these last two are our logical operators for predicate logic. Again, you don't really have to pay attention to these for now. However, I think it is worth introducing. In predicate logic, we incorporate a universal quantifier that's represented by this upside down A, and you can think of this as the for all operator. In predicate logic, we work with a domain of discourse, and this is essentially a demarcated set of things that we work with within the language of propositional logic. A set of items, you can think of it that way. So we can say something like, for all x, hx. And in propositional logic, in predicate logic, the capital letters are predicates rather than propositional variables. So h here, we can say it stands for the predicate is human. So when we have hx, we're just saying x is human. And here, we're just quantifying over all of the items within our domain of discourse, and we're saying that for all x, x is human. And our last one here is our existential quantifier. This is represented by the backwards e here, and you can think of this as the there exists at least one operator, and we can have something like there exists an x such that x is human. And one more thing to keep in mind within the grammar and syntax of propositional logic is the use of brackets, braces, and parentheses. You can refer to these as our groupers. And these groupers help us disambiguate expressions within the language of propositional logic. So let's say we have something like J or S and M. So this expression is rather ambiguous because it can be expressed in two different ways. So let me copy this over. So the first way in which we can express this expression is by putting our groupers around the disjunction. The second way is by putting the groupers around the conjunction. And both of these have different meanings. The top one is saying that I will see John or I will see Sam and I will see Mary. However, the bottom one is saying something a little bit different. It's saying I will see John or I will see Sam and I will see Mary. It's important to keep in mind that these groupers really help to disambiguate our expressions, and they help to better convey the actual intention that we're trying to convey to other readers. Most of the time, you will see parentheses. Occasionally, you'll see braces, and very rarely will you see brackets. The brackets are really they're special cases. Let's say we have a very complex expression, and the writer wants to be extra careful in how they present it. They may incorporate the use of brackets. Most writers, however, or maybe not most, but a lot of the time, you'll only see parentheses. So we can have an expression like open parenthesis S and open parenthesis P or Q, close parenthesis implies A. And this would still be a permissible expression within the language of propositional logic.